name is Katrina Alexander, and this is Week 7 Interactive Advanced Concept Presentation, Balloon Models of Molecular Geometry. So how do we determine the shape of a molecule? We can really only determine the shape of a molecule through experimentation, but we use a model. We use a model to predict the shape. And this is the Vesper model, and we also use the Lewis structures along with our Vesper model. But the Vesper model accounts for electron pairs in the valence shell repelling repelling each other, which gives the molecule its shape. In the Vesper model, or based on the Vesper model, it states that electron domains repel one another and they will arrange themselves to be as far apart as possible. And their 5 adopted geometries are formed, their 5 adopted shapes are formed. The 5 major electron domain geometries, I'm going to apologize, I'm going to scoot the computer in front of me. Sorry, we are at a different location. We are without power tonight at my house due to a tree falling on the line. Okay. This is why I'm sitting on the floor. The 5 major electron domain geometries are linear, trigonal planar, tetrahedral, trigonal, bipyramidal, and octahedral. And remember, when we're discussing electron domain geometry, we base the classification on, of course, the number of electron domains. For example, if you're looking at the total number of electron domain, you can use table 9.2 in your book. For total number of electron domains, 3, the electron domain geometry would be trigonal planar, for example, and the molecular geometry with 1 unbonded lone pair would be considered bent. An example would be SO2. For our first shape, this is our linear geometry with the 2 pairs here bonded in the middle. You can see by the nice straight line. And example of a linear would be O3. O3. Okay, for my second, sorry, I'm having a little trouble with these balloons. For my second electron shape, trigonal planar, would be our 3 balloons bonded here, our 3 molecules bonded here, and together along with the central atom. And they're just 3 balloons in a trigonal shape. A trigonal planar would have 3 electron domains. The type of molecule would be AB2, and the molecular geometry again would be bent if there were 2 lone pairs considered as a total within the 3 electron domains. An example would be SO2. For my third molecular geometry is a tetrahedron, and it is like the trigonal planar but with an extra added balloon at the top, making it a total of 4 domains. And the electron domain geometry is considered tetrahedral. It has the type of molecule would be AB3 or AB2, and for the molecular geometry term would be trigonal pyramidal, and an example would be NH3. My next shape would be considered trigonal bipyramid, and I'm sorry I had a little trouble getting this last balloon to stick, so I'm going to hold it up and show you that it looks just like our tetrahedron, but with an extra balloon attached at the bottom. So you see your 5 electron domains represented by the balloons. There are, in all of these, of course, 5 electron domains, but for trigonal bipyramidal, you have several types of molecules. You would have AB4, AB3, and AB2. Examples of AB4, an AB4 type of molecule would be SF4, and that would be considered seesaw shaped. An example of trigonal bipyramidal AB3, the molecular geometry would be T-shaped, and that would, an example would be chlorine trifluoride, chlorine trifluoride, I'm sorry. And an example of AB2, trigonal bipyramid, would be AB2, and the molecular geometry would be linear. And it would be, I have 2 iodide fluoride, 2 of negative charge. And okay, for our very last would be square bipyramid or octahedron. And it has 4, 5, so you have 6. Should have 6. Double checking myself here. I'm not really good at making these models, as you can tell. Should have 6 electron domains, and it does. So, for example, AB5 would be one of the type of molecules, and its molecular geometry with 1 lone pair would be square pyramidal, and for AB4 octahedral with 2 lone pairs, its shape would be square planar, which I discussed earlier. An example of the aforementioned is xenon fluoride, or xenon F4. So I hope this kind of gives a good understanding of the shapes, at least, of the electron domains geometry. Thank you.